Okay, we're back here, part 2, continuing on where we left off. Just more examples of some logarithmic or exponential equations that you're going to be working to solve. Number 8 here, I'm going to go ahead and subtract 8 from both sides. So I have 3 natural log of x is going to equal 6 minus 8, which is going to give me negative 2. The natural log of x is going to equal negative 2/3. And don't forget, this is base e, right? So this converts to e to this power equals that number. So if I'm interested in what x equals, x is going to equal e to the power of negative 2/3. And when we bring that up, let's see what e, oops, wrong one. There it is. E to the power of negative 2/3. It's approximately 0.51. So that's about what x is equal to. Similar problem here. First we're going to divide by 4, so I have log base 6 of 3x is equal to 12 divided by 4 is 3. So a few different ways we can go about this one. One would be to kind of do what we did up there and say, well, this means that 6 to the 3rd power is equal to 3x. Which means if you take 6 to the 3rd power, you get 216. So we have 3x is equal to 216. And x is going to be equal to 72. Now the other way that I was referring to here, let's do this in green. It's going to give the same exact result, but it would be to say, well, I'm doing base 6, so let me take 6 to this power and set it equal to 6 to this power. So if I did that, 6 to the power of log base 6 of 3x is going to equal 6 to the power of 3. Well, if you really think about what this means 6 to some power equals 3x. Well, whatever that power is, I'm taking 6 to that power anyway, so I'm going to get 3x equals 6 to the 3rd power. I mean, you'll see I have exactly what I had down there. So, same result, just a different way of thinking about it. Here we have, we're going to take advantage of the fact that we know that this means that when I see 2 logs of the same base being added, I can also think of that as the log, in this case, log base 3 of, I'll write it this way, x minus 4 times x minus 1. Because we know if I take the log of x times y, that's equal to the log of x plus the log of y. I'm using the same principle here, basically. So now, since I have the log base 3 of something equals the log base 3 of something, these two somethings that I have, which I'll underline in red, must be equal. So at this point, with this problem, I can get rid of the logs right now, and let's work on just the algebra. So x minus 4 times x minus 1 gives me x squared minus 5x plus 4. Double check that. Negative 4, negative 1, negative 5, yes, is going to equal x squared. Well, when I subtract x squared over, I'm left with negative 5x plus 4 equals nothing, equals 0. If I proceed from here, negative 5x will equal negative 4. Therefore, my x is going to equal positive 4/5. Okay, another problem here. This time I've got subtraction of logarithms with the same base, so using our rules, we know that that means the log of a fraction. So I'm going to put x plus 5 over x. Okay, this here means the same thing as this. And that right now is equal to 3. Well, this would be really nice if I could get the right side written as log base 4 of something, and then I can just set the two things equal, get rid of the logs, and I'd be good. So what I'm going to direct my attention to now is asking myself this 3 here. If I have log base 4 of something that I don't yet know what it equals, but I know that this entire thing is going to equal 3. Oops, that's the 3. What's the thing here? Well, this means 4 to the third power equals x. So let's ask ourselves, what's 4 to the third power? Well, 4 to the power of 3 is 64. So basically, another way of writing 3 is log base 4 of 64. This is 3 because 4 to the third power equals 64. So when I think of it this way, what I really have now, I have the log base 4 of this fraction x plus 5 over x is equal to the log base 4 of 64. And so hopefully you see that I can set this x plus 5 over x equal to 64. I can get rid of the logs right now. So we'll go over here and do that. So x plus 5 over x equals 64. So x plus 5 is going to equal 64x. Subtract the x over, that's going to give me 63x. And so to get x by itself, I'm going to divide both sides by 63. So I can just leave it as 5/63. That's actually better than the decimal answer, so that's actually preferred. That's exact. Okay, we'll wrap it up here with another problem here. This one, a word problem. I encourage you to dig around the word problems in the section. But this one, suppose you invest $5,000 at 8% annual interest, but it's compounded continuously. Now, if you remember, PERT, as I heard some of you refer to it in class the other day. Here's our formula for continuously compounded interest. Okay, so if we're gonna, oops, I'm sorry, I wrote that wrong. Hold on. Something didn't look right. All right, so this is the amount that I have. This is the amount that I started with. This is the number E. This is our rate. This is the number of years. So how long in years? We don't know what T is, but everything else we should know. If I'm talking about doubling my money, I start with 5,000. That means I'm going to end with 10,000. The interest rate is 8%, so I write 0.08 times T. Well, when I divide, regardless of what dollar value I started with, I didn't even have to tell you what I was going to start with. You could start with $2 and this problem's going to work out the same because you're going to double it. When we divide over, regardless, we're going to get 2 if we're talking about doubling our money. So I have 2 is equal to e to the power of 0.08 times t. So if we take advantage of the fact that we know we can take the natural log of both sides, because this is base e, I can take the natural log of the left side and the natural log of the right side. Well, this remains natural log of 2, but on the right side, remember, this is e to some power equals this. Well, that's going to be 0.08 t. I can see that being a source of confusion for you, but if you think about it long enough, that will make pretty clear sense. So what I have to do here to find out what my t is I'm going to take the natural log of 2, which I'll type into my calculator, and I'm going to divide it by 0.08, and that should give me what I need. So we'll type that in here. So natural log 2, and we'll divide that by just 0.08. So it's going to take approximately 8.66 years. I won't make you convert that into months. You can just call it 8.66 years, good enough. But I'd like for you to think about how, make sure you understand how to change that into months. What we'll try here in this section, again, it's just a random assortment of equations to solve. You got to see a lot of these to get comfortable with them and be familiar with the techniques we're using. We'll try the multiples of 3. I don't want to give you all of these problems. That's going to be quite a bit. But there are problems throughout this assignment that are worthy of doing. So let's start with this. Hopefully this should be all we need to do. Based on the questions that you guys ask me, we can go ahead and look at some more problems in class. Good luck with it.